let f of x equal 5x squared plus 24x plus 16 all over x squared plus 26x minus 45. Nicely, they've already given this to us in both expanded form and factored form. Many times that's very useful whenever we're determining different aspects of the rational. Starting off, the domain and interval notation. So the domain is going to be all the values where the function is defined. And these are going to be all the values where we don't end up with division by 0. So division by 0 is going to occur if I take these factors in the denominator, set them to 0 and solve. I've got x equals negative 9 halves. And then if I take 4x minus 5 and set that to 0, that gives me x equals 5 fourths. So I need to make sure I don't include these values in my domain. So the domain and interval notation will be all the values from negative infinity to negative 9 halves, and then from negative 9 halves up to 5 fourths, and finally from 5 fourths to positive infinity. So on a number line, it's essentially giving us all the values from negative infinity to positive infinity, but I have open circles at these two particular values. Now, the Y-intercept. The Y-intercept is easiest to get in the expanded form. In the expanded form, it's just the ratio of constant terms. So the ratio of constant terms is just going to be these two values right here divided. So a y-intercept does occur at a point, so you need to make sure you write it as a coordinate pair. The x value of the y-intercept is always 0. Then 16 over negative 45. I don't think that reduces, so we'll just list it as negative 16 over 45. If you were to graph this, you might want to change it into a decimal just to make it an easier location to find. But since we're not graphing it, we'll just leave it as is. All right, the X-intercepts. These occur at the places wherever the numerator is equal to 0. The numerator is equal to 0 where these factors are equal to 0. So just like I did with the denominators factors, I'll do that with the numerators. But the X-intercepts occur at points on the graph, so we need to make sure we write them as points. So if I set 5x plus 4 equal to 0, I would get negative 4 fifths, and the y-coordinate would be 0. Similarly, if I take x plus 4 and set that to 0, I've got a negative 4, and then the y value is also 0 there. Vertical asymptotes, those occur wherever the denominator is 0, which we've already determined over here. So we have the equations of the vertical asymptotes already. It is x equals negative 9 halves and x equals 5 fourths. Now these are actually vertical lines, and so we leave them as equations and don't write them as points. So as written is perfect. Then the horizontal asymptote. There are 3 different rules when comparing the degrees of the numerator and denominators to work with when it comes to horizontal asymptotes. In this case, the degrees are equal, so I take the ratio of the leading term coefficients. So it's going to be y equals that ratio of leading term coefficients, which are 5 and 8.